Hi, it's Mrs. Tellas. We're going to go through this Mr. Potato Head review for sections 3.1, 3.2, and 3.3 to get ready for our quiz. So if you have any questions that you don't understand, this would be hopefully where we explain it to you and you're able to do it. Are able to get your questions answered. If not, please email me. So here we go. This is called a mapping. The ordered pairs, they match up on the line. So -1, 7, 0, -3, 0, 7, and 1, 10 are the four ordered pairs. You can tell there are four because there's 1, 2, 3, 4 arrows coming off of this is the X oval, and this is the Y oval. The domain would be all the X values, so -1, 0, 0, and 1. And the range would be the Y values, so 7, -3, 7, and 10. And it is not a function. And the reason it's not a function is because there's repeating zeros in the domain, or this output is paired with the same output is paired with same input is paired with two outputs. Okay, the domain and range. So the domain for this one is between the x's. So the most far left it is here, and the most far right is here. And you can also see that it gives you the numbers right here. For the domain, they're the x's. So I write this as a compound inequality because it's a range. It's between. So I'm going to write -2 first because that's my small number, and 4 last. And I'm going to put x in the center because it's domain. And see how these are open circles? This would be less than for both. Okay, the less than and the less than show that it's between. So this says between 4 and -2, but not including them. So if I do the range, I do the same thing. I just do it for the Y instead of the X. So let's change colors here. So that would be the highest point is right here, and the lowest point is right here. And again, the numbers are given to you. Okay, so the range, I put my smallest number in the front, which is 1, and my biggest number in the back, which is 3. I put Y in the center because it's the range, and I put less than because they're both open, so I can't put less than equal to. So if I do the same thing over here, let's start with the domain again. You should press pause and try this if you haven't already. So the domain is between 1 and 7, and it includes 1 and 7. And again, you can see the numbers in the ordered pair. So 1 and 7 with an X, and since they're closed, it's less than equal to for both. And the range is where it is top, the highest point, and the lowest point. And again, you can see it in the ordered pair. So it's between 2 and 6 with Y in the center. And again, they're closed, so it's less than equal to. All right, so if I graph the function, this f of x means the same thing as y. So it's just going to be a linear function. Okay, because I can write it in slope-intercept form. So I'm taking these values, easy values, and plugging them in. So -3 times 0 plus 5 would be 5. And you could just type that into your calculator, into Desmos. And that's a positive 5, not negative. So -3 times 1 is 2. So that's 1, 2. And -3 times 2 plus 5, let's see, that's -6 plus 5 is -1. So -2, -1. And then I just graph them. So 0, 5 would be up 5. 1, 2 would be right 1 and up 2. And right 2 and down 1. And it makes a straight line. See if I can draw a straight line. Hey, not bad. Okay, so f of x is the same as y. And this is definitely linear because it's a straight line. We could also ask if it's a function. And it totally is. Look, if I draw a vertical line anywhere, it only hits one, so it's also a function. So it's a linear function. All right, same thing. So we're going to take the f of x and make it a y. So x is first, the function is second, this part, y is third, and then the ordered pair. So I pick easy numbers for x, which is 0, 1, and 2. Those are my easiest numbers, and I plug them in. So 4 times 0 is 0. So 0, 0. 4 times 1 is 4. 4 times 2 is 8. So there are my ordered pairs. And all I did was take the numbers and put them in for x each time. Okay, so if I graph this, 0, 0, 1, 4, and 2, 8. So you need to make sure that yours looks like mine on your paper. Your chart and your table should be there. It's linear. It's a function. F of x is the same as y. Okay, and if you did like 1, 2, and 3, you plug 3 and it'd be 12, so it'd be up here a little bit. Okay, you don't have to do 0, 1, and 2. Those are just easy numbers that I like to do. Okay, this is function notation. So what we're doing here is we're taking this 3 and we are going to plug it in place of x right there. So negative 6 times 3, if you put that in your calculator, is negative 18. Same thing here. If I take the negative 4 and put it in place of x, so negative and negative 9 are just part of the problem, and then in place of x, I put negative 4. And if I type that into decimals, that makes negative 5 is my answer. Okay, so this is just another way of writing this. So I'm just taking the numbers and plugging them in for x. Taking this number, the second problem, and plugging it in. So let's do the yellow one first. We need a regular pen. There we go. So 7 times negative 2 minus 6. See, that would be negative 20 if I type that into decimals. And 7 times 10 minus 6 would be 64. Again, if I type it into decimals. So all I did was take the x out and put these numbers in them and then put that into decimals. All right, the cost f of x of renting the atrium banquet is $500 down and $100 for each hour x that you're there. And here's the function. It's right here. Okay, and it tells us in the words what those stand for. So it says f of x is the cost. So this is cost over here. And this x right here is hours. Okay, so x represents hours and f of x represents cost. And I didn't just make that up. I took it from the words. It says if you rent the banquet hall for 12 hours, see how this is hours also? How much does it cost? So you take the 12 and you put it in right there where it's hours. So I'm going to change this to y. So y equals 75 times 12 plus 500. So my calculator is right here. So 75 times 12 plus 500. So it costs $1,400 to rent this banquet hall for 12 hours. Okay, and if I do the same thing, if I paid $875 without tax, that's my cost. How many hours? So this time I'm going to plug it in over here on this side. So the same function, but I'm going to plug it in over here. So 875 equals 75x plus 500. Now your solving skills kick in. So we're going to subtract 500 on both sides. And then we're going to divide 75, which I know that you know how to solve. So 375 divided by 75 is 5. So that cost would have been for 5 hours. Okay? All right, is it a function? So this is a vertical line test, big time. Okay, so I take my line and I draw some vertical lines, and it only crosses once no matter what, where, so it's yes. Okay, this is also a function because no matter where I draw it, it only crosses once. Let's see on this one. Only once, no matter where I keep drawing it. This is a function. This one's not because it crosses twice. This is not a function. This one's not because it crosses twice if I draw it right in the middle. This one is because it only crosses once no matter where I draw the line. Oh, this one actually is the same, isn't it? Oh, it's just smaller. So this is a no. And then this parabola, this is yes. Okay. All right. Write the relation, domain, and range, and if it's a function. Remember, relation just means it's the ordered pair. So we're just going to write down what the ordered pairs are in the mapping. So here we have negative 1, 5, 0, 3, 1, 5, 2, 11, and 3, 21. Okay, the domain are all the x's. So it's the first number in the ordered pairs. So negative 1, 0, 1, 2, and 3. And the range are the ones that aren't highlighted, the y. So 5, 3, 5, 11, and 21. And yes, it's a function. And it's a function because all these x's are different. So I look specifically at the x's or the domains. And if they're all different, which they are, then it's a function. If any of them repeat, it's not a function. Okay, let's do it for the chart now. So if I write the relation, which is just the ordered pairs, it sounds a fancy name for that. Negative 1, 5, 0, 3, 1, 4, 2, 7. Mr. Potato Head's in my way. And 3, 4. Okay, and then I write the domain. Remember, that's just the x values. So negative 1, 0, 1, 2, and 3. And the range values are the ones I didn't highlight. So 5, 3, 4, 7, and 4. Okay, and again, to decide if it's a function, I look at the domain. All of the domain numbers are different. So this is a function. So yes, this is a function. Okay, and I've got a graph here, which is the same thing. I just need to write down the points, the domain, the range, and if it's a function. So let's do that. So for relation, let's see, this would be negative 6, 4. B would be 7, 6. And you don't have to go in this order. You go whatever order you want. So negative 3, negative 8, negative 2. E is 5, 0. And D is negative 4, negative 7. Okay, so there's all my points. I think there's 5 of them. Yeah. Remember, your domain are all your x's, your front numbers. So in the book often puts them in numerical order, but regardless, it doesn't matter if you do that or not. Okay, and then the range are the ones that I didn't highlight. The second ones are the y's, so 4, 6, negative 2, 0, and negative 7. And then to decide if it's a function, again, I look at the domain, and if all the domains are different, which they all are different numbers, then yes, this is a function. Okay, Tiana says that all of the graphs are nonlinear. Her friend Abby says she's wrong. Explain who is correct and why. So all of the graphs are nonlinear. Remember that nonlinear means not a line. Well, I look at the first one, and this one is a line. It's linear. This one's nonlinear. She's right about B. C is linear. It's a straight line. This one's nonlinear. She's right about D. This one's nonlinear. That's an oval. And she's right about that one. So she's wrong about A and C. Those are the ones she's wrong about because they're straight lines. Therefore, they are linear. Okay, so to figure out which table is linear and nonlinear, we calculate the slope for it. So we're going to do the change in y over the change in x. And we're going to try to figure out linear is constant or consistent, and nonlinear is not. It's varying. So as I look here, what happened to the number? It went up by 3. It went up by 3. It went up by 3. Top number is 3 because they're all the same. And then over here, we went up by 1. So bottom number is 1. This one's a linear table because it's got a slope of 3 over 1. If I do this one, this goes up by 5. This goes up by 8. 5, 8. Let's see, 33 to, that's plus 9. And then the last one, 42 to 48. That's 6. These are all different. I could write 4 different fractions here. So far, it's looking very nonlinear. They would end up having to be equivalent to be linear. And these are all just plus 1. So these are not equivalent. They're all different. So this is a nonlinear table. Okay, and then I put 2 tables on here that are sideways rather than up and down. Same thing. I start down here with y, and I'm looking. It's a very long table. So plus 5, plus 5, plus 5. Look at all those plus 5s. The slope is 5 over something. And then here I've got plus 2 everywhere. All the way down, the slope is 5 over 2. So therefore, it is linear. My guess is this last one's nonlinear, but let's look. Again, we start with the y because that goes on top. So that's plus 7. That's plus 19. Ooh, I don't know what that is. 64 minus 27. Let's use my calculator. That's 37. So again, I have 3 different numbers. The only way these could be linear is if they're exactly equivalent, and they're not, I don't think. So look here. These are all plus 1. So 7 over 1 and 19 over 1 and 37 over 1 do not equal each other. They're all different. So this is nonlinear. Okay, it says move the equation to this correct category of linear or nonlinear. So let's move them. So this would be linear because remember what I'm looking for. I'm looking for y equals mx plus b. Categories I look for an x and a y. If it has one or both, I look for no exponents. M and b are just numbers. They can be fractions or decimals. So those are the kinds of things I look for. So this one's definitely linear. Oh, I'm writing on it. I didn't mean to do that. Let's try again. Linear. That one's linear because it's got a y with no exponent. See how these have exponents? These are nonlinear. This one's linear. It's got an x and a y with no exponent. Oh, I left the 1/2 behind. Still linear. That's got an exponent. This one's linear. That one's linear. This one's nonlinear. It's got that square root symbol. And this one's nonlinear. It's got that little 3. Okay, and then this one's definitely nonlinear as well because x is in the denominator. Okay? Okay, all done. So on the quiz, we're going to be doing function notation. You'll have to know domain range from graphs, mappings, tables, and relations, and decide if something is a function or not, and decide if something is linear or nonlinear. That's everything we've done in 3.1 to 3.3. So if you have any questions, email me. Thank you for listening.